Okay, now we're going to change it a little bit. And I'm going to have n equals 16 in here. So I really don't want to do it this way, in the sense that I could keep track of all this. It's fairly simple to do this arithmetic down here by hand. But when you've got 16, you might want to enlist the help of your TI and try to set this up systematically like so. We can see this time our delta x will be 2, well, b minus a over n, which is 2 over 16, which is an eighth. Okay, so it changes by 1/8. Our first value of x, we'll say, here's the sum we're trying to make. I equals 1 through 16. And we want f of, we'll call it c sub I, and the delta x. The delta x are all the same. So the c sub i's are, in this case, we're going to take those all on the left side of each rectangle, because that will give us a lower sum because of the concavity of this curve. It gives us inscribed rectangles, which is what we want. So you can see that the c sub I literally could be written this way. C sub I would be the okay, so here's what we have. C sub I, in general, if you're using that left endpoint, will be a plus I minus 1 delta x. So that's for a left side of your rectangle. If you were going to use the right side, just to make a note, if you were going to use the right, it would just be c sub I equals I delta x. Okay. So and I runs from 1 through 16. So this would be right sides. Okay, we're using left side, so we don't need that. Now, I've put that in. A is a 0, so I have c sub I equals I minus 1 over 8. Delta x is 1/8. Throw that into our sum here, using our function 2x squared plus 1. And we got that times an eighth delta x. So I can write that this way. Now this, I can do this by hand and maybe enlist the calculator a little bit, use some formulas to, some formulas to reduce this, but it's gonna be a lot of work. And since I'm only going to 16 and I'm not trying to generalize this to n, I will just pull out the calculator at this point and get it into the calculator. So as a reminder here, we're going to pull up the list formula, and I'm going to do a 2 and 1 here. I'm going to do a sum, okay, and then I'll come back in here, and this time I'm going to put the sequence in. So you can do it like this as long as you are clear on that sequence. So now the sequence is this. We'll go with x again, x minus 1 squared, quantity squared, and that's divided by the 32. And you're going to add a 1, and you're going to put a comma. Oh, and I shouldn't forget my 1/8. I'll go back in and put that in, but I'll put a comma here, and then I'll put in my x and my limits here, which are from 1, some lower, to 16. And then you would close that off with 2 parentheses, because that was the sequence needed a set, and then the sum needs a set. Now I'm going to go back in. The thing is, this whole thing is being divided by 8, so I can just put the 8 out here, divided by 8, the whole shebang divided by 8, and then go ahead and press enter. Okay, so there's my estimate. It's approximation, 6.84375. Okay, I just put that over here, 6.83475. Okay, 6.84375. I got those two mixed up. Come back in here. Okay. All right, so that's that number. Notice that it is bigger than this one was. This was a lower sum, this was an upper sum. Not only that, but when you increase the n, you will get something closer to the actual area because we're making these little wedges in here smaller and smaller. The more rectangles we have, the smaller those little edges become, those little corners. So they tend to be less and less in error. So these are the two numbers. This is the number we got for the 16, n equals 16. That is a lower sum.